In this tutorial, I'm going to introduce the Winson WCS current sensors. I've written a library for all these series of WCS current sensors from Winson, where you can measure the currents from very low value of milliampere up to 50 ampere or higher, and the library will work with all of them. As you can see, my electronic load shows 20 ampere, and on the serial monitor we are reading also 20 ampere. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. Winson Semiconductor from Taiwan is producing tons of Hall effect sensors, and these are the versions. As you can see, they go up to 40 ampere, 50 ampere. These are the versions that you can solder the wire directly on the sensor, and also they have through hole versions. These are all the versions, and 200 ampere, 100 ampere, and different values, but they have different sensitivity. Sensitivities are shown in here. That they all consume 3.5 milliampere, which is very minimal and acceptable for many applications. And these are the sensitivities. Keep in mind, if you are purchasing any of these values, try to select the one that has highest sensitivity, because you will get better result. But the problem is, for example, this one has very high sensitivity at 5 ampere maximum. So the higher the value that you select, the lower the sensitivity becomes. For that reason, I've selected the 35 with 66 milliampere, and there was also 35 ampere with 70. So this Winson WCS sensors are offered in many shapes and form. They made it on PCB. They made them also as a big, larger module with even LED display with attached relay and so many other features. So the library that I have written will make it very easy to use all of them. I've seen a lot of requests and also existence of these current sensors from Winson. They're available on Amazon, AliExpress, eBay, everywhere. I decided to write a library for this. So you can use all Winson WCS. There are different series, but these are WCS series, which are the majority of them, over 15 or 20 types. So you can use them with Arduino and will be able to measure the current. So I've implemented a zero current recording. When there is no current, always all the current sensors will read some value, so we have to save that, and then later on when the current is connected, subtract it. In order to be assured that the zero current have been saved, I've implemented a LED indicator here that have been connected to pin 2 and ground via a 300 ohm resistor. So once the value is saved and recorded, this will turn on, while letting you know that it has been recorded, so you can proceed with turning on your load. So this will be used when the load is not connected, and within 5 seconds it will record it. You can change the time and make it 1 second, 2 seconds, or even more. It's very flexible. The library is very flexible. You just select your model and some very basic settings, and it will just work fine with all the WCS sensors. When connecting the wires, all WCS sensors, they have 3 wires, and the 3 wires are labeled as VDD, ground, and Vout. All of them. VDD will be connected to 5 volts of Arduino, ground will be connected to ground of Arduino, and the pin that is labeled Vout will be connected to analog 0. And each module has datasheet, and on the datasheet they're all aligned in the same way. So we have VDD, ground, and Vout. So you can get that from the datasheet for each module that you have. For example, this is for WCS1800. And if you have this type, VDD, ground, and analog out, or for this one as well, the same way, VDD, ground, and analog out, the pins are connected in the same way. For example, you might get a version something like this, that you have to solder your 2 wires in these 2 pins, and then these 3 pins are power supply, ground, and the Vout for the current. And the version that I'm testing today is 1800, and I've chosen this because it goes up to 35 ampere and it has just 3 terminals. Very simple. Either you can use it like this, which is very linear, 66 millivolts per ampere, and the module is sold like this, or maybe just a bare module. The code that I've written will work with all of these. You might find it in a black or blue version. Pay attention when you're wiring the bare module without the PCB. You have to connect between the V out and the ground. We need to connect a capacitor 0.01 microfarad, that is 10 nanofarad, to 0.1 microfarad, which is 100 nanofarad, to reduce the noise. But if you're getting PCB, the capacitor is already included. This is a capacitor. And on this module, this is a capacitor. It's already included. A separate video for all Winson current sensor, where you can display the current on LCD, either LCD 2004 or 1602. I will also show you how to control a relay or disconnect the load when the current reaches a certain value. So you can control, using a relay, you can turn on and off a load at certain value. I will have separate video showing you how to use this potentiometer to control a relay based on the current, so you can disconnect a load or connect the load at certain amount of current. Make sure to subscribe. Here's the datasheet for the Winson WCS1800, the Hall effect sensor. The diameter for this hole is 9 mm, and you can measure AC and DC current. 0 to 35 ampere, 66 millivolts per ampere is the sensitivity. And this needs operating voltage, which can operate from 3 to 12 volts, and it needs 3 milliampere current. Isolation voltage is 4000, so it's directly related to the supply voltage, and bandwidth is 23 kilohertz. And for AC, you can measure up to AC RMS up to 25 ampere. They're in negative or positive direction at 25 degrees Celsius and 5 volts. This is the output that we are getting when there is no current. We are getting 2.5 volts if we are connecting it to 5 volts. That's very important, pay attention. So this module will always output 2.5 volts, but it will fluctuate from 2.35 to 2.65. So keep that in mind. This is actually the sensitivity at 10 volts. They have measured it, so it is 66. And here is the error. You might get 56 to 66 to 76. So from 56 it goes 10 up and 10 down. DC 35 and 5 volts RMS 25 ampere. And temperature drift, when there is zero current, it will be plus minus 1 millivolts per degree Celsius. So every degree Celsius will add 1 millivolts. Keep that in mind. This is the negative of my power supply, and that's the positive. The negative I've connected directly. This is the load. I'm connecting it to my load. And this is the positive, passing it through this, and will be connected to my load. This is my load. And here I've prepared this wire. This is the 10 AWG wire that can handle over 70 ampere. So I'm going to connect it like that. And now let's see, this is your load, and you have a battery and you have a sensor. Doesn't matter which sensor you have. You can have this type of sensor without a PCB with a hole through, or you have the sensor, this shape of sensor that will pass hole through, or maybe a module, something like this, that the two wire will be connected here, which I'm going to show you, or this module, or this type with the two terminal on the side, or if you have something like this, or something like this. You can put it between the negative and the load, or you can put it between the positive and the load, or you can put this one between positive and the load, and it will just pass through that. Or you can put it at the negative, the same module here. Or if you have this type of module, you can solder the two wires between the negative and the load, or between the positive and the load. And if you have this PCB version, you can connect the two wires in this two terminal, or between the negative and the load. And if you have this shape, you can also connect it between these two terminals, something like this, or between the positive and the load. When connecting the wires, all WCS sensors, they have 3 wires, and the 3 wires are labeled as VDD, ground, and Vout, all of them. So VDD will be connected to 5 volts of Arduino, ground will be connected to ground of Arduino, and the pin that is labeled Vout will be connected to analog 0. And each module has datasheet, and on the datasheet they're all aligned in the same way. So we have VDD, ground, and Vout. So you can get that from the datasheet for each module that you have. For example, this is for WCS1800. If you have this type, VDD, ground, and analog out, or for this one as well, the same way, VDD, ground, and analog out, the pins are connected in the same way. And here for the module, this pin is VCC. Using green wire, I've connected to pin 8, where we define this pin in the code as VCC for the module. And then the second pin is blue. Blue is not connected here, I just taped it. And then this purple is ground. Ground is connected here to ground of Arduino at this pin. And then the last pin, gray, is analog out, where we read the current. It is connected to analog 0. And for 0 current detection, we need to prepare an LED with a resistor. The LED has 2 pins. The longer pin is positive or anode, the shorter pin is cathode, and we need to put a resistor between something like 300 to 1 kilo ohm. The value doesn't matter, because if you put larger value, the intensity of light will be reduced and there is no harm. So we will connect the anode, this longer pin, to the resistor and solder it, and the other pin of the resistor will be connected to 5 volts. In this case, we are going to connect it to pin 2 of Arduino, and the shorter pin is connected to ground. And here is the schematic for the above. So we have 5 volts goes through a resistor, and then to diode, to the LED light emitting diode. This is anode, and the side that has line is cathode, and it will be connected to ground. And then LED that I've just shown you, I've prepared, it has been connected to ground and pin 2. Let me explain the code. The first thing that you need to do is download the library that I've written, download it as a zip file and save it in your computer somewhere. And then on Arduino, click on Sketch, include library, add .zip library, and then point it to where you have saved it. For example, inside the PC, download and tutorial, and this, if this was the zip, select it and click open. The library will be installed. After that, close Arduino, make sure at the bottom there is no other instance, so there is only one. Close them all and reopen it. After that, click on File, Example, and scroll down, and you will see Robojax WCS current sensor. Under this, you will have a lot of examples. Click on WCS basic. So this is a basic current measurement, and this is the example that we are opening. All current sensors from Winson are listed here. This is the model, and this is the model number. And because we are using WCS1800, our model is number 12. So from this list, you have to find the model that you're using. Here, this is a wire that is for display, in case if you're using it with a display. And this is the Robojax WCS, that's a library that you just downloaded, and the model, you type it here, 12. And this analog 0 is a pin. We are defined it here as sensor pin. We are reading the voltage from the sensor at this pin, and we are defining a separate 5 volts at pin 8, because I'm going to leave the main 5 volts for display and other purpose. This needs very little current, 3.5 milliampere. And then the 0 current LED pin, one pin is needed to be dedicated for LED, so pin 2 in this case. You can change these pins. And 0 current wait time, this is the time that we wait before the LED is turned on, this LED. And I found through my experiment that this is a correction value. Either set it 0 or increase or decrease it through experiment to get proper value. But in my case, I put 165. At iteration is 100 measurement. We are doing 100 times calculation and getting the average. If you want more accurate value, increases like 300, 500. And then the voltage reference, this is the supply voltage. I put this because sometimes you might supply your device with 12 volts, for example, 10 volts, and it can work, no problem. so we can put that voltage, but I would suggest keep it at 5 volts. And bit resolution, this is Arduino Uno, majority of Arduino are 10, but if you're using Arduino DUI or MKR, they are 12. They're 12 bits. Debug once is a value that displays the debugging information on the screen, and if you set this to true, it will display once. I'm going to show you this. And here, this is from the class we create an object called sensor, and all these values that I've just explained will be passed here one by one with comma. So we are passing them to this class of library. Inside the setup, we are defining the serial monitor with 9600. If I click here, and on the right side in this section, you see that these are numbers. 9600 is the number that must match, otherwise you will not be able to see it. This is printing that text. And then sensor.start will start the sensor with all the settings. This line is printing the model that you're using. So anytime you need the model, sensor.getModel will give you the model number, and in this case we are using it as a print. Let me open the serial monitor after 5 seconds. It will display it here. Here it displays that's the model, WCS1800. Inside the loop we have to do this, and inside the loop we put this sensor.readCurrent. It must be inside the loop, otherwise you will not read the current, but this is optional. Sensor.printCurrent. When you put this, you will see the current on the serial monitor here. This is a value here, and if you don't want to do it, display it, just comment this and it will not be displayed. And if you want to get the current and do something, for example, sensor.getCurrent will return the value. So this is a value you can do, add, subtract, multiply. This is a number, and here we check it if it is greater or equal than 12.3, and then do something. If you want to do something, then open and closing parentheses here, and you can put your code here. I will have a separate video explaining this, how to control a relay to turn on and off a load when the current reaches a certain value. And then we have 500 milliamp loop, and the loop will continue taking the same action. And here we have print debug commented out, and if I uncomment this and then upload it, now if I open the serial monitor after 5 seconds of zero current, the debugging information will be displayed. This is the model, and here we are reading all these values. So this is very useful in case you want to make sure that the settings are correct. For example, sensor model is this one, and how many times you are reading, debugging, and then the reading from analog 0. So do not worry, after pin 13, analog 0 is pin 14, and VCC pin is 8, and then the sensitivity. For example, you enter the wrong value, you will see this one, and then zero current voltage 33 millivolts, which have been recorded, and then voltage reference 5 volts, correction value, bit resolution, and wait for zero current. So you get all these information. To not see them, just comment this out and it will not be displayed. Now if you set this, because this is debug once, if you set this to false, upload it, now if I open this, wait for 5 seconds, the value is displayed continuously. It reads it and displays it. In case if you want to connect the load and check and read, I don't know, whatever, for whatever reason, if you want to display it continuously, do that. So I'm commenting this out and setting this back to true. Now let me demonstrate it. When you turn it on initially, within 5 seconds that you can set in the code, the zero current indicator shows that the zero current have been recorded. So this is an LED that is telling us the status. And if I press the reset button here, you will see here, and it shows that a zero value set to 3.23 ampere. That's why now this LED is on. Turning the load with 5 ampere. Now the 5 ampere is entered. Let me turn it on. So 5 ampere is now passing through this cable, and we are reading 404.8, so almost 200 milliampere deviation. Let's go 7, again 300 milliampere deviation. 8, the deviation have been consistent almost. 9, so 10 ampere we are getting 9.6, so 400 milliampere. Let's go 15. Now 200 milliampere, so now it becomes very accurate. 16, 17, 18, very accurate now. 19, 100 milliampere deviation. 20, so now we are half ampere above the value at 20. Let's go 25. Now it's 25, and we are reading very close value, almost 100 milliampere deviation. Let's go 30. Now 30 ampere is passing through this cable, and we are reading almost 1.5 ampere deviation less. So now it's 1.5 ampere less, 28.5 almost. Let's go 35. So we are reading 31, so 4 ampere deviation. So at 35, this is not working properly. So it's not linear. Now let's go 30. Let's go 30. Reduce it. So at 30 also was almost 1.5 ampere. So 25 is the best value that you are getting. It's very close, accurate value. So let's go 1 ampere, even smaller value. This is almost 120 milliampere deviation, but very better than other values. Let's go 0.5. So 500 milliampere, we are reading it at 390 or 400, so 100 milliampere deviation. Let's go 10 back, jump. So half ampere or 450 milliampere deviation. So conclusion is that we can get up to 25 ampere and not above that. So this is the result. Now this is now 25 ampere, and let me show you if I now the load is connected, and in case your Arduino boots up, this is what happens. I'm pressing the reset button, and pay attention now. I'm stopping it. You see it recorded 28.5 for the zero current. Remember there was 3 point something and now 25. That's 28.25. So if you forgot it, that's what we read now. Let's see if I turn this off. Now you read minus 25 ampere because nothing should before there was going the current. Now the current is stopped, so now minus 25 is being recorded. For that reason, make sure that when you boot Arduino, the load must be disconnected. So let's reset it again. And as you can see, it has recorded 3.27 ampere, and it is on now. We can trust this, and if I turn this on, 25 ampere is shown properly. Thank you for watching. This was how to use the Winson WCS current sensors with the Robojax Arduino. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it in the comment section below. I try to answer and reply. And to get updates of my upcoming videos, make sure to subscribe. In this tutorial, we're going to learn how we can use this Allegro current sensor WCS750. They are available in a range of from 50 to 200 ampere. I'm going to test it with 50 ampere. This is a serial monitor, and this is my load, electronic load, that is taking 50 ampere.